Hello everyone, I am Pratik Vibhute and I study in MIDU SY Civil Engineering, and today I am going to explain about permeability. Now we see definition of permeability. Permeability is a property of a porous material that determines how easily fluids flow through the interconnected voids of that material. Here gravels is a highly permeable and sticky clay is least permeable. Now we see duration of permeability of each layer. First, gravel. Its duration is 2 minutes. Then sand. The duration of sand is 2 hours. Next, silt. The duration of silt is 200 days and the duration of clay is 200 years. Now we see units. Permeability is defined in the units of area open pore space in the section that force or is perpendicular to the direction of flow. The common units of permeability is Darcy, after name of a scientist. Here we see which factors affecting on permeability. Textural properties, pore size or grain size distribution, shape of grains, packing of grains, gas slippage, amount, distribution and types of clays, type and amount of secondary porosity, overburden pressure, reactive fluids, high velocity flow effect. Now there are two types of permeability. First is absolute permeability, second is effective permeability. Now we see absolute permeability. The measurement of permeability or ability to flow or transmit through a rock conducted when a single fluid or phase is present in a rock known as absolute permeability. Second, effective permeability. The ability to preferentially flow or transmit a particular fluid when other immiscible fluids are present in the reservoir. For instance, effective permeability of gas in a gas water reservoir. Here we see this diagram. Now we will see the study of permeability is important for estimating the quantity of underground water. Then next, investigating problems involving pumping seepage of water for underground construction. Third, analyzing the stability of earth dams and earth retaining walls subjected to seepage forces. And fourth, the adequate permeable soil and water holding capacity result in the good plant growth. Last, filter made of soils are designed based upon their permeability. Now we will see the operational procedure of permeability. Here, the coefficient of permeability of a soil describe how easily a liquid will move through a soil. It is also commonly referred to as the hydraulic conductivity of a soil. This factor can be affected by the viscosity or thickness of a liquid and its density. The number can also be affected by the void sites or region of non-soil void continuity and soil particle shape and surface roughness. It is an important factor when determining the rate at which a fluid will actually flow through a particular type of soil. Coefficient of permeability depends not only on property of soil but also on the property of water. Now we see determination of coefficient of permeability. The coefficient of permeability is divided in four such types: laboratory methods, field methods, indirect methods, and capillary permeability test. In laboratory methods, constant head permeability test and variable head permeability test are present. Now in field method, pumping out test and pumping in test are present. In indirect methods, computation from the partial size and from consolidation test data are present. Constant head permeability test. This test is used to determine the coefficient of permeability of a soil. This is important in examining The movement of contaminants through soil or when characterizing flow nets. First, quantity of water that flows under the given hydraulic gradients through a soil sample of known length and cross-sectional area in a given time. Second, water is allowed to flow through the cylindrical sample of soil under a constant head. Third, for a testing of previous coarse grained soil. Now we see the equation. K is equal to QL upon AST. Here K stands for coefficient of permeability. Q stands for total quantity of water. L stands for length of coarse soil. T stands for time and H stands for height. Now we see variable head permeability. Relatively for less permeable soil, water flows through the sample from a pipe attached to the top of the end cylinder. The head of the water changes with the time as flow occurs through the soil. At different time, the head of water is recorded. See, K is equal to 2.30 AL upon AT log 10 H1 upon H2. Here T stands for time, L for length of the fine soil, A is cross sectional area of the soil, small a is cross sectional area of a tube, and K for coefficient of permeability. Now finally we see application of permeability. It is a very important engineering property. It finds its application in many aspects. Some of the application of permeability are following. First, filtration. Second, water treatments. Third, solving problems involving pumping, seepage water from construction excavation. And fourth is the design of earth dams is very much based upon the permeability of the soil used. Thanks for your appreciation. Thank you. Thank you so much.